So welcome everybody. So this is one of the seminars in our series of seminars. We have every week one talk. I'm really glad to see that there are several people, colleagues from Polyphonia project. It was, it's not surprising given the topic of the seminar. That's really good. I hope it will become a habit to have you with us. But by the way, maybe some of you already heard that we are planning to organize in autumn a monthly seminar within the project context. So, and of course, we will discuss together the calendar and build the program together. This could be one of them. Andrea Portroneri, some of you already know, well, the people from our team, of course, know him, but also the people from Polyphonia know him because he is involved in the project. And Andrea recently got his master degree, and this thesis actually explored already this topic, which is extracting patterns from music content. But I think I can say without offending him that it just scratched the surface of the problem. So he's learning. And now he has just proposed a program for his PhD. And actually today he had his interview for the PhD scholarship. So hopefully, if everything goes well, he will be soon a PhD student working on this topic and within the Polyphonia project context. So today, actually, he's going to tell us what its project about. So it's not going to show us results. Actually, it's going to show to explain to us what he thinks he wants to do. And then I think he will also tell us a little bit about what he did during his master thesis and how this connects with the PhD program. So actually, let me invite all of you, as usual, to discuss at the end of his talk. But in this case, I would say it's particularly important because Andrea is here eager to get inspiration, suggestion, criticism, anything that can help him improve his plan and identifying the right direction and inspirational ideas for his PhD. So this is mainly a project proposal. So what we do usually is that we give the speaker 30 minutes at most. And then we have time for discussion after that. So Andrea, I will warn you when you have 5 minutes left, but if you have a timer, please also use your
Yes, I've got my own timer, so.
Okay, anyway, I will do something when you have 5 minutes.
Thank you.
And so please, the stage is yours.
Thank you very much, Valentina, for the introduction, and good afternoon to everyone. As Valentina said, today's seminar will be twofold. I am going to present my PhD proposal and my master thesis and some results from my master thesis, and I'll explain how these two works can connect. Talking about my PhD proposal, the main objective of this proposal is to develop algorithms for the automatic extraction of music patterns having musicological or perceptual relevance. But first of all, what is a music pattern? Well, a music pattern is defined as a musical fragment, which can be melodic, rhythmic, or composed by intervals, for example, that is repeated within a music piece. Here you can see a small example of music patterns. These are couples of melodic patterns, while here we have a bunch of rhythmic patterns, so rhythmic fragments that repeats multiple times, while here we have some interval patterns, so the same intervals that repeats here in these occurrences. The extraction of relevant music patterns can be helpful for different application and for different purposes. For example, in the context of cultural institutions, music patterns can help managing and searching within large music catalogs. While for musicological research, music patterns can allow to recognize citation and references cross-song, and can allow the analysis of quotations and citations between different historical periods and between the repertoire of different composers, for example. But they can also be exploited for commercial purposes, for example, for streaming services like Spotify, as they can support music classification and music suggestion algorithms. In music, we can find different kinds of recurring structures, but as stated by David Meredith, some of them are not relevant, neither for a domain expert nor for a non-music trained listener. So the purpose of this proposal is to extract two main kind of patterns, namely patterns having a musicological relevance, which are those patterns usually referred to as music themes, which are basically the basic thematic idea of the whole piece on which the piece is built on, and pattern having a perceptual relevance. This is intended in the broadest sense possible and refer to the part of the music piece that is best remembered by a listener. The annotation of these types of pattern have been carried on historically manually by domain expert, by musicologists, but in the past few decades, also some computational methods have been developed in order to carry on this task. The first approaches were string-based, and they only focused on symbolic notations, while some other approaches, for example, the ones proposed by Vellard, proposed to extract patterns from the audio signal as well. And these approaches are based on the assumption that audio signal can contain some features that are not contained in the symbolic notation, but that can be helpful and relevant for the pattern extraction. For example, the same fragment proposed by the first violin can be perceived differently if proposed by the second violins. Other approaches are based on the extraction of patterns having musicological relevance, so the so-called music themes. And these approaches, for example, the one proposed by Sukhavasi, are focuses on either audio signal or symbolic notation, rarely on both of them. Also, contextual information of the pattern, for example, the chord that's played behind the pattern proposed, are not taken into account in all these approaches. There are some approaches, for example, the one proposed by the Ruse, that take into account contextual information, but only focuses on symbolic notation. So my contribution is would be in extracting different patterns and understanding which of them can have a musicological or perceptual relevance, starting from heterogeneous sources, so both audio and symbolic notation. To the best of my knowledge, this approach haven't been explored before. I then plan to work on multimodal resources, which would allow me to observe in a combined way both score and audio. And I also plan to take into account patterns contextual information. To do this, I first of all need to build a corpus. The corpus should contain both symbolic representations and audio recording for each song. The corpus will also be balanced by inserting tracks from different genres and different music tradition, and of course, from different authors and composers. From the corpus, I will have to extract features and represent them formally into a knowledge graph. To do this, I plan to use semantic web formalisms and model these features by means of an ontology. In order to do this, I first of all need to identify the set of features that can be relevant for pattern identification and extraction, and of course carry out research about the state of the art of semantic technology that can allow me to represent music features. Since my intention is to extract patterns from multimodal sources, I will need to align different representation systems. To do this, I plan to reuse state-of-the-art algorithms such as dynamic time warping, which is the best, the more used approach for this task. My knowledge graph will also contain annotated musicological patterns and annotated perceptual patterns. But how to annotate these types of relevant patterns? Well, it depends on the type of pattern. I plan to extract to annotate musicological patterns starting from already available data sets of annotated musical themes. While for perceptual patterns, since there is no data set, to the best of my knowledge, containing perceptually relevant patterns, I plan to run a crowdsourcing campaign in order to let users to annotate audio segments. In order to do this, I also plan to implement a small game or a small application, maybe connected to Spotify, that can allow also non-expert users to annotate this section of audio. So I will have my musicological patterns annotated symbolically, while my perceptual patterns annotated on the audio signal. But my knowledge graph will allow to infer correspondences between the different representation systems. Then my knowledge graph will become the training set and the test set for machine learning algorithms that aim to extract relevant patterns from unseen data. I will explore different algorithms for this task, such as knowledge graph embeddings, and I plan to run deep learning algorithms from that, like recurrent neural network algorithms. Moreover, since this work starts from a formalized representation, I will try to investigate and abstract over the findings of this research. So trying to understand why a certain pattern can have both a musicological or a perceptual relevance. So this was my PhD proposal, and now I'm going to present you my master thesis, my final dissertation in digital humanities and digital knowledge, called Using Semantic Technologies to Support Music Representation Interoperability and Musicological Analysis. The supervisor of the thesis was Professor Gangemi, while my co-supervisor was Professor Meronio-Pinuela. And I'm presenting the thesis because it proposes some approaches for solving some of the issues presented in the PhD proposal. The main objective of my thesis was to propose an ontological model. For doing so, I first analyzed some problems of current musicology, contemporary musicology. And first of all, I've analyzed limits and challenges in musicology, and I've analyzed some music representation systems. These two analyses led me to the definition of features that can help me solving these problems. And these features were formalized into the ontological model proposed. Talking about limits and challenges in musicology, musicology literally means the study of music, And I started from the classical subdivision of musicology into subfield proposed by Guido Adler in 1884, who divided musicology into historical musicology and systematic musicology. While the former focuses on topics usually studied by humanistic disciplines, the latter have a more scientific approach. Talking about systematic musicology, the connection between music and science comes from the ancient Greece. And nowadays, these subfields of musicology focuses on empirical psychology, acoustics, neurosciences, cognitive science, but also computing and technology. From an epistemological point of view, I've also carried on a research on differences between the scientific research and the humanistic research referred to the musicological domain. And it came out that, of course, scientific research is empirically and based on observation and deals with data-intensive field, while humanistic research rely on different research methods and deals with data-scarce field. Talking instead about computational musicology, which is another recent subfield of the discipline, it would allow the transition from a data-scarce field into a data-intensive field, but the transition has been quite slow and still today has a greater impact outside of the humanities. In fact, most of the research is carried on by computer scientists instead of actual musicologists. This analysis brought me to the definition of my first research question, which was how to hold different aspects of musicological analysis together in order to make computational research more comprehensive and efficient. I then analyzed music representation, which is strictly connected to musicology, since it's what makes musicological analysis possible. And I evaluated different music representation systems based on two parameters, namely expressive completeness and structural generality. And I divided the music representation systems analyzed into four main categories. The first one is signal representation, which is a physical representation. And while it is very expressive, it provides almost no structured data. Symbolic representations, on the contrary, are very structured by definition, but does not provide the same expressiveness compared to the signal representation. We also have vector representations, which are based on the assumption that we don't need neither signal representation nor symbolic representation in order to represent music, but we just need vectors. And these approaches are mainly based on, mainly used for machine learning application. And then we have knowledge representation, which are based on formal logics and foster the interoperability between different representation systems. These are all the symbolic representation system I've analyzed for my research, and these are all the knowledge representation systems I've analyzed. And after this analysis, I came up with my second research question, which is how to represent music for musicological analysis in order to catch as many aspects as possible. In order to answer to the question raised, I defined and extracted some features. All these features were extracted by using Python programming language and were extracted both from symbolic representation and signal representations. First of all, I've aligned signal representation and symbolic representation systems. To do so, I've used dynamic time warping algorithms from the Librosa library, which is a kind of naive approach, but it worked for easy and for not complex sounds. And this approach was based on the conversion of the symbolic representation into an audio signal and aligning the two resulting sounds. This approach works good with not complex sound, for example, piano sounds, and does not provide good result with very complex sounds. For example, sound coming from a symphony, for example, which is full of different instruments. Then from the symbolic representation, I extracted, first of all, metadata, for example, the metronome mark, the time signature, the instruments annotated on the notation. And for extracting all this information from the symbolic notation, I've used Python library, which is Music21. By using Music21, I've also extracted some melodic features, some music pattern in this case, but differently from what I've presented before, this pattern does not have any relevance, neither musicological nor perceptual. It's just an approach based on n-grams that aim at extracting recurring structures. I've also extracted some harmonic features. For example, I've extracted chords progression, dissonances, and the tonality of the music piece. For doing so, I've used the Chordify module of Music21. From signal representation, I've extracted structural features. I've used for this task the MSAF framework, which is based on Librosa and provides is a framework that provides different algorithms for boundary detection and segmentation. And this is an example of the segmentation provided by this algorithm. And I've also extracted some emotional features. For this task, I started from a dataset labeled on Russell's circumplex model of affect. And I trained a neural network by using a recurrent convolutional neural network algorithms that performed 77% in accuracy. All these features were then put in an ontology. This is like my model, and I describe in this model, first of all, the contextual the metadata features, so the author, the name of the composition, and for that I've used the music ontology, which has been aligned to my ontology, which is called Hamse ontology, which aims to represent all the feature extracted and all the feature extracted from the symbolic notation in particular. All these features were then aligned by means of the timeline ontology to the excerpt of the audio signal where these features were actually played. This ontology also allowed me to align and to represent symbolic notation, so a composition, and to align it to many different performance of the same composition. Concluding this project, proposed a semantic model for representing musicological, for helping musicological analysis, and allows the alignment between different representation systems. Moreover, by connecting different aspects of interest for different subfields of the musicological domain, it is possible to connect, for example, information of great interest for psychoacoustics with information usually analyzed by historical musicology, for example. So what are the connection with the pattern mining proposal I talked about before? Well, the Hamse ontology could be a starting point. Of course, this is just a starting point of an ontology for representing music features. And also, I plan to reuse the audio to score alignment that, of course, has to be improved, but can be reused for the proposed pattern mining application. Also, some of the harmonic and melodic features extracted could be helpful and relevant for contextualizing the music pattern I intend to extract and formalize. Thank you.
Okay, thanks, Andrea. Actually, you were particularly short, so we have plenty of time for discussion. Thank you very much, and I would really like to open the discussion, and waiting for your hands raising. So please raise your hands if you have any question. In the meantime, there is a question already in the chat from Aldo, who's actually, so maybe while the others think at possible comments or questions, we can, okay. Okay, so I will read. So Aldo, Aldo was the first question about musicological patterns. He asked, you mentioned themes, and is asking if you are also considering forms. Maybe you can better clarify what, if you have already identified what types of musicological patterns are under your lens, or I don't know if you already know it, but you can answer this question.
In which sense forms?
There I am. No, hello. No, of course. So the point is that you may have much different material that you want to discover or want to detect, or to. So when you talk me about themes, I typically think about particular melodic fragments within, or maybe melodic plus harmonic. But there is another type of pattern-like structure that is used in music, which is the musical form. This could be, songs that have a typical organization of the AAB or AABA, or more evolved forms. So I'm just considering, this is just one example, the kind of repeating patterns you can find within music. So if you have investigated the difference between these things. So I imagine that you are more concerned about thematic material, of course, no? But
yeah. So far, I just focused on music themes, also because I could find out some data set of already annotated music themes. So so far, I didn't focus on the extraction of forms, for example, but yeah, it's absolutely interesting as a suggestion, and I can focus on that as well, because it's a really interesting hint.
There is also Anna Sofia Lipolis. She says she cannot talk, but she's asking, and by the way, welcome Anna Sofia, because she's one of the latest acquisition of STLab. We will have the opportunity to welcome you properly. She's asking if you can give examples of perceptual patterns.
Thank you, Anna Sofia. Well, the idea of perceptual pattern is not yet defined in this work, and I was talking about perceptual pattern in the broadest way possible. But the idea is to let people, mainly non-expert users, non-expert musicians, to annotate what's, in their opinion, the part of a music piece that they can remember easily, or the part of the music piece that reminds them to this particular song. That's the very general idea, but of course, in this research, I will need to formalize better what I intend for perceptual pattern. But this is the basic idea.
Okay. Any other comment or question? So Martina.
May I ask a question? Thank you for your presentation. Was really interesting. From what I got from your presentation is that your work is basically on detection of patterns in music. I was wondering if the methods that you are you plan to develop can be used to generate music and to let's say give agents the opportunity to generate music.
Yes, of course. One of the secondary purpose of this work is also providing like systems with this set of relevant patterns, and maybe trying also to explain why these patterns can be relevant. And this kind of work could also be very relevant in the field of automatic composition and machine composition. So this is definitely a point of this research, because by means of the knowledge graph I aim to implement, we can also have a lot of information, both harmonic and melodic, and we could have the opportunity to understand why some occurrences are relevant or not. And this is something that for machine composition is far from being achieved, in my opinion, since most of the approaches are based on variational autoencode from machine deep learning algorithms, and so basically the neural network do not have any idea of what's going on behind. And in fact, one of the main problem in machine composition is understanding the long-term structures, which is like the main structure of the composition. And this work could also help in this perspective.
Okay, there is a Bruno Sertini who has a question. Please, Bruno.
Hello. Thank you, Andrea, for the presentation. I was wondering if you were planning to include in your research also maybe something about lyrics of musical pieces, and if so, what you want to do with that, if you want to study them as well, maybe find some patterns that are linked to the content of the lyrics of a song. I don't know.
Thank you, Bruno. Yes, of course, it would be a very interesting add-on to my research, in the sense that we can also retrieve patterns from textual information. And so there are also some works, for example, searching to retrieve music structures for analyzing patterns in textual context. There's also a lot of work dealing with natural language processing for lyrics. And it would be also interesting analyzing the relationships that music patterns can have compared to the lyrics. And for example, when dealing with perceptual pattern, trying to understand whether a pattern is influenced by some lyrics or by the sentiment that's behind these lyrics. And yeah, so analyzing this interrelation between the emotion aroused by text and the emotion aroused by music, it would be really interesting. And also interrelating these different kind of patterns would be really nice. I didn't put anything in my research project about lyrics, because there's a lot going on only looking at the musical content, but I'm definitely looking forward to work also on textual data.
Thank you.
Okay. Okay. Misael has a question. He wonders whether approaches like BERT for text can be applied in this context by building a model that predicts a missing part of a song.
Thank you, Misael. I am not an expert of BERT. I just have the broad idea of how it works. But yeah, I think that approaches like it that can help understanding and predicting missing structures, missing musical structures. So yeah, analyzing by learning these repeating structures, trying to find the most likely probability of having a certain note after specific pattern, or the probability of having a certain pattern after a recurrent structure. So that's something that I definitely want to explore as well.
Thanks. Jacopo just sent a link to let us know that just published really recent on Archive an attempt to, so it's a paper, Music BERT, Symbolic Music Understanding with Large-Scale Pre-Training. In fact, I was thinking, well, of course, I didn't read it because I just know about it thanks to Jacopo. And actually, but I'm curious to read it because I think you need to build something like a music model instead of a language model, right? And it must take, you know, huge resources. And I'm even wondering if it makes any sense to do this.
Yeah, thank you very much.
Aldo also has sent a link to another paper. Oh no, this is the same. So Aldo and Jacopo had the same looked for the, anyway, so definitely a paper to look into. I think that what Andrea wants to investigate is not really intended to, yeah, of course you can use it for informing this kind of models, but I don't think, Andrea, you're looking for generating music or things like that, right? Maybe by the way, guessing what's next if you have blank parts of a music piece can be a way also to see whether your approach works. But I mean, it's really now too early to discuss this kind of things. But yeah.
Yeah, I'm not really interested in music generation in my project, but it's something.
Yeah, no, of course, it's an application that is one of the possible applications.
Super interesting application, of course.
Is there any other comment or questions here? So one, okay, no, there is one, so I give priority to the, but I don't see, so I see it. Okay, Peter, please, Peter, go ahead.
Yes, yeah, thank you for this presentation again. And I think it's a very fascinating topic, as we all agree, I think. I was just trying to understand still the reason for you to make these two broad categories, like musicological patterns and perceptual patterns. Is there a theoretic reason behind that, or is it just pragmatic? So what is the rationale of that?
Thank you, Peter. Well, my main idea was to deal with musicological patterns, but then I decided also to explore the possibility of extracting perceptual patterns, since I think it's something that can be even more efficient and more interesting, more relevant for example, for music suggestion algorithms, since it's something that is annotated by humans, by normal listener, by everyday listener. So it's something that can be very relevant in that way. This dichotomy is just casual, let's say, and I plan to bring my research on these two parallel ways. So it's something that I will use like the same approach, but I'm keen on looking for both kind of patterns.
Okay, that makes sense. Thanks. Would you expect musicological patterns to be a subset of perceptual patterns?
Yeah, I expect something like that, but I'm not sure that there's like a perfect correspondency between the two of them. But it would be really interesting to analyze if actually musicologists annotate something that is relevant for normal listeners. But it would be really interesting as an aspect of this research.
Okay, thanks.
Thank you.
Yeah, I think indeed that in the context of our project, we can try and do this. I mean, Andrea's work, if we manage to have annotations from non-trained, not music trained people. So if we find a way, so Andrea thought we could maybe develop a sort of game or something so that we can ask people to just tell us what's the fragment of a piece that they that they remember strongly, so, or that they associate to that piece. And so it would be, so it's really, I think it would be really a strong and interesting resource to have such annotations from the general public, let's say, and then see whether there is any correspondence. I mean, whether there are, musicological patterns, let's say, that which are the result, in my understanding, they are the result of theoretical studies and top-down definitions and things like that, to see whether empirically and from more a perceptual viewpoint, they have any connection. I think this would be really interesting also for musicologists to see whether, for example, there are structures that are interesting from a perceptual viewpoint, and maybe they didn't consider them, but they can reconsider whether they can be abstracted in some way. Yeah, that's certainly something that to me is really, really interesting. Okay, so
yeah,
thanks Peter for the link. Marco, yes, please.
Can I
sure
say something? First of all, Andrea, very congratulations for your presentation and the subject you are dealing with. It's very interesting, and I think you are opening a door to the multiverse of musicology, because if we consider the repetition the key word of the musical pattern, I understand also the question by Aldo Cangemi on the forms, because the repetition is the base for perceiving a form in music. So we have madrigals, we have ballata, we have a ballade, French ballade that is different from ballata in a formal point of view. And the repetition of patterns is the way the form is constructed. So this is the point. But we have also to consider, maybe you can add this point to your research, the social pattern, musical pattern, because the repetition, if I well understood what you have done, you have considered just today the repetition within a piece, but we can also consider repetition among several pieces. I'm referring to a phenomenon that it is well known in musicology, that is the musical gesture, that is that are the musical some musical patterns that are associated to a code, a social code, and the simple way, the simple fact we find only one occurrence of this social pattern in an opera, melodrama, in a piece, permit to the public to remind the musical gesture and to associate it to a significance. So we have maybe, besides the repetition, you can add also the significance, relevance of a musical pattern. And this is another dimension. On this topic, there is a book that is specific on melodrama by Marco Begelli, a Bolognese musicologist from Bologna.
I know him.
And he deals with these aspects, the musical gestures in melodrama, and the fact that the public was aware of these significance that were behind a musical gesture, and the repetition in this case is the repetition among a lot of pieces. So we have a code that is created in the mind of the public through the fusion of several pieces and several melodrama. The fact that the same melodic pattern, or the fact that this melodic pattern is played by this instrument or another one, for example, is associated to a particular significance. And so the fact that we find it in the same situation in another opera, this is relevant. This is an example of repetition, but not in the same piece. So we have also, I wanted to invite you to consider also the repetition among several pieces, and so in a repertoire, for example.
Thank you, Marco. I think it's really fascinating. I didn't read anything about this kind of pattern so far, but I will definitely go through it and read something about that, because it's really interesting, and I think it's something that could add
the title
to my research.
Marco Begelli's book is La retorica del melodramma ottocentesco, something like that.
Okay, thank you very much.
Thank you, Marco. And there is also Giancarlo, who joined late. Giancarlo Succi, welcome. And he joined very late, so probably missed also the short discussion we had about the distinction between perceptual and musicological patterns, these two categories that Andrea defined to distinguish patterns that are like studied and defined, recognized manually by experts that study music, and the perceptual patterns, meaning, what we all as general non-music trained listeners consider patterns in the sense that we recognize a piece because of that specific fragment, or we like the piece particularly because of that specific fragment, or it gives us specific, strong emotions, things like that. And I think his comment/question is related to this, because he asks, of course, Giancarlo, you're welcome to open your mic and do the question yourself, answer the question yourself.
Okay.
No, thank you, because again, my apologies. I find this discussion extremely interesting, and also the last comment was very interesting. So I know practically nothing about music, so my apologies if I will say something totally outrageous and wrong. But I'm a software engineer, I'm a programmer, and we try to we say that we copy pattern from a musician. Now, what we are trying to do now is to see if we there is some sort of mental activity which is similar between developers and musicians. So we record the EEG by students who are also musicians and developers. So we record and we try to find analogies. And now here we have a question, right? The developer have patterns, musicians have patterns. Does the same mental activity occur in these two cases? And if so, since music has a tradition which is of thousands of years, why coders don't? Can we learn something from you? That was my question. But indeed also what Valentina, what you said now, right? The fact that there is a perceptual pattern, and I don't remember the other term that you use, but a pattern which reflects on how you do, right? One is how you listen and the other is how you do. This is also something which triggers to me interest. I never thought about it, but it could have the same implication in terms of software development, because there are patterns on how you perceive the software, right? And patterns on how you develop the software. But for the first question, I don't know if you also consider this more, how can I say, more physiological aspect of the pattern of music.
Yeah, thank you, Giancarlo, first of all. I went through some papers about the perception of music, and indeed there's is proof that our brain perceives music associating notes to sounds together, and it perceives music from a very low level through patterns, to the association of different sounds into patterns. So that's really interesting. I'm not a neuroscientist, and I would need the help of domain expert to go through in depth in this domain. But I find it really interesting and inspiring.
If you say that there is proof, well, I don't know this literature actually, Andrea, if you can forward it to me. So if there is already some observation that our brain perceives or behave in a sense as a reaction with the music, and you can actually recognize certain patterns, certainly this can be something at least we cannot do. We cannot do this kind of neurological experiments, but we can reuse the results of existing experiments. So what Giancarlo was saying actually to me is more like, so to look into the brain means to at least collaborate with some neuroscientists, which is even feasible, but maybe a little bit far from what we have planned for this initial, our first plan, okay, let's say, where we want to look at the data mainly. But if there is already some results and maybe some data set with data that reports, that represent these observations, we can try and see whether there is any connection between what they found and what we can observe with the, for example, annotations from the crowd or things like that. So we can, I didn't consider this, but I think we should keep an eye on, take this into consideration if there are data available for reuse.
Yeah, my research was really high level, but I was able only to find like papers explaining how like these mechanisms within the brain work, and no data or data set about that. No, that okay, brain works associating patterns, but we don't know what these patterns are. But of course, I can research more in depth into this field, and let's try if there's some data about that, and it would be really, really interesting.
As what Giancarlo, you said about the analogy between software and music, I never thought about it in this way. So it's interesting what you say. I mean, to me, there is always this tension between what you define because of your experience or your knowledge about a field, and so like design patterns in software, or we do study ontology design patterns in knowledge representation, and which is similar, and then the empirical aspect, meaning the observation of what actual people do. For software it means what actually software engineers do. For ontology design means what ontology engineers do, and so on. So we do this research in ontology engineering, like looking at what the data that are published tell us as compared to what the good practices recommend, and see whether there is an actual matching between the two, or if we discover new things. And I think a similar approach is what Andrea is suggesting for his PhD, looking at both sides, like what musicologists have defined and studied, and what people recognize in terms of perception. But as for software, this is a bit out of topic, but I was curious, what do you mean when you say how we perceive the software? I mean,
yeah. So first, why, right? Why do we do this? Because we have found that there is a bazillion number of software engineers who are also musicians, but really incredible. So, you know, you name in Agile method, Kent Beck is a musician, Alistair Cockburn is a musician, is a dancer. So I said, perhaps there is something in common. And then you go and you perceive at a high level analogies, like everyone can be defined as a musician, right? Everyone can learn in 2 days on how to put the hand in a guitar, and everyone can claim to be a coder, right? To write 2 lines of code in 2 days. But to become proficient, you need 10 years, 12 years, 13 years in music, and you also need a life in software. So, and in both cases, it is creativity plus a lot of discipline and a lot of theory. So, in this sense, we said, okay, so there is a ground. And then we said, okay, so software has patterns in it, patterns of development. We know design pattern. And now I heard music has pattern. So right now, what we were doing is we were asking people to write code and asking people to write code with music and observing if the theta waves were different when they were doing. And then we were asking people to play music, but the people are our students, right? So to check, and this is ongoing in the summer. I have summer interns who are doing this. So if you ask me the result, I have no idea of the result. It's done by first and second year bachelor students. So perhaps there will be no result, right? We don't know. We just measure, we try. But I think the analogy, and then now you triggered me the interest. You said something I was not thinking about. You said, well, but music is not just composing, it's also people listening, right? So, and actually, I don't remember the guy who talked before you, who was talking about Melodrama, and so he was talking about, Marco was talking a lot about musical pattern. This is all about people listening. And then I say, wow, but it's also true that there are also software, people who use software, who see the software and perceive a pattern in the software. And actually, I don't know how you want to call. I mean, we don't have Melodrama in software, whatever, but we do have different kind of user interfaces, right? You have a Mac, you have a PC. So there are styles of presenting information. There are people who like command line tools, people who like Windows. So can we compare, can we draw analogy? And then what interests us? Can we see similar brain activity widens? Because in software, it's very difficult to do perfect software, right? Like in music. And so what we want to know is we want to know what are the mental conditioning under which people perform better software. Suppose there is a tragedy, you know, there is a Fukushima, we need to fix a bug. How can we put a person in the good mental state? What do we need to do this? And this is why we think that we can learn from musicians who have experimented this over the years to understand what are the mental conditions where this works best and try then to recreate it into software. That's why I find what you are doing extremely interesting.
And I'm curious a lot about the results of your experiment. Actually, I think we should keep in touch.
Absolutely. I mean, we can come there actually with a EEG cup and measure all your brain activity since you're a professional and then get the results.
Yeah, no, I think so. Definitely, it would be interesting to keep in touch and exchange, you know, data about our research and see whether there is also, you know, the opportunity to reuse each other's results.
Absolutely.
Or data.
You have an open invitation to come here anytime.
Thank you very much. Yeah, no, I'll get in touch. I'll get in touch, and also, we have this project Polyphonia, which is focused on musical heritage and in particular to produce data about music based on knowledge extraction, which means extracting both from a signal, from notations. So Andrea's work is clearly, you know, developed in the context of this project. And the project is relatively young because it has like 6 months now, and it goes ahead for another 3 years. So there is certainly, so you may want to follow us in a sense and interact, because we have, at least we plan to have a networking activity to get from other researchers, but also other experts, let's say, that work with music, to get from them both data and additional use cases. So for example, our data can inform other experiments and things like that. So I'll certainly get in touch, Giancarlo, to follow up with this. Thank you very much for the input.
Thanks to you.
Is there any other comment or question? So Andrea, as you can see, you have many eyes on you. So your PhD must be a success, otherwise you will let down that many people. Okay, so if so I don't see other hands raised. It was really interesting. Thank you all. Very nice to see you here. All the colleagues that are not in our team, it's very nice when you join us. We really like it. And so maybe we'll see you next week. I don't know what's in the calendar. I don't remember, but you would get the usual reminder in the mailing lists. And I mentioned already, we publish all the seminars in our YouTube channel, so it will be there in probably tomorrow or in a couple of days, so you can find it there. Thank you again. I'll see you next time. Grazie, Andrea.
Thank you all.